time. What do? We got Christmas special. That's what I do in Christmas time, and I can't think of anything fun to do. Got an idea. This lab looks too sciencey and not Christmassy enough. Take a look. All those motors and broken electronics waiting to be dismantled. It's time to put some Christmas cheer around here, and it's time I build an alarm system for Santa Claus. Maybe you can do this too, and maybe you can try it out for yourself. But don't try the dangerous experiments. You do these outside for safety reasons. Let's get started. Now, what do you think can be improved over here? I can certainly put some Christmas lights over there. Can build a heater and an alarm system for Santa Claus. Let's do that. Let's start with the Christmas lights, because they're the safest and the easiest to build. So the construction of Christmas lights. The construction of Christmas lights can be really simple. And to do them without having to buy tons of bulbs, just get some broken Christmas lights. Here. No. Headphones. No. Like these. Here they are. And plug them in the mains. But what's the science in that? I want to make now 12-volt Christmas lights. And then it's how you make them. Watch. So to make the Christmas lights, we need to get some, as I said, lights from old Christmas lights. I have to cut them out. Some Wagos for safety, sake and for a good connection, and some wires from old electronics. In this case, I got 2 wires from 2 old fans. The more lights you want, the more wires you need. And I also have to get 1 more light bulb from Christmas lights, because 1 burnt out in my experiments. Strip 1 out, like this. Strip another 1 out, and we have 2 more bulbs. Good enough. Let's strip the wires. So after stripping the wires on the bulbs, we get 3 bulbs like this. 3 bulbs, 1, 2, and 3. And we get each of their contacts, 1 pair, only 1 of their contacts of 2. We get all 3 of them, twist them together. We're going to connect 3 of them in parallel. We get another 3, and we connect those together as well. So we're going to wire the 3 bulbs in parallel with each other. This, you see, you fold this in half. So that fits in the Wago better, like that. We get 2 3-pin Wago. 3-pin later. I'll tell you why 3-pin later. So we open the last one of the tree. This one. We fit this bulb. We fit one of the bulb wires in to make a good contact, and we close it. And now the bulbs are in tight. And we do the same for the other one. Open, shove bulb contacts in, and close. And that's 1 bulb pair done. Now, we get the wire that we want to make our power supply, which is this, in our case. We're connect these 2 to the power lines, not the 230 volt, the 12-volt ones, because the power supply adapter. And these 3 go in the... And these 3 go in 1 Wago pack, like this. Open, shove 1 wire in, and close. And same for the other one. And now, before you ask, the green wire is because this wire was used in high voltage. This is going to be used in low voltage, and which is why we don't need it. And also we don't have any metal either. The only metal is inside glass, which is an insulator, so we're set, we're safe. And so this is how it's supposed to be, and the earth we put in a Wago. Like that. Always use Wagos properly, or else it won't turn out so good. And there you have it. And then, to add more bulbs, we get another wire, and because this is And you repeat the process if you want to do more bulbs. But because this is my last set of bulbs, I get the other 3 bulbs. 1, 2, and or the third one. And now we get our other wire to connect more bulbs to the circuit and fit them in the last pair of the way it goes. And that's why we needed 3. I think you got why now. 1 for the live and 1 for the neutral. In this case, the earth is not needed because 1, the voltage is low, and then the current is direct, so it's even less dangerous. And there's no exposed metal in the circuit, so we're good. Or potentially exposed metal. And even if there were, as I said, the voltage is low. So now shove the live wire in, and the earth wire to the other earth wire we go. Like this. Good. And then with the other wire, which is this, we have 2 pin. And we get our 3 bulbs. And we repeat the process. Get the 3 wires, tie them together to connect the 3 bulbs in parallel. If you connect them in series, they'll be very dim because you have a voltage drop across them, and it won't end well. And we need bright bulbs, not low current draw. And we use for the other pair as well. Like this. And there we go. And we shove it all the way go. Like that. And as usual, we shove it in the positive and then negative, like so. And we do this. Shove it in the neutral. And we isolate the earth because it is not needed for the time being. In fact, it's not needed at all. And here are our Christmas lights. And to tie the bulbs, you have to connect them over the hedge like that. You have to connect them over that part. So, as you saw. And then you have your own desk lamp and Christmas lights. Great. And let's plug them in a power supply, which in this case is this. This can take up to 1.2 amp on the secondary as a load, and these bulbs barely draw 100 milliamps, so we're good. So now the output terminals are these, with this, the white streak being positive, and the completely black one being negative. And here we have the wires. Let's plug them in. And by the way, polarity doesn't matter because these aren't light emitting diodes, they're filament bulbs. Because keep in note that these are very old Christmas lights. I got this from a very old string of Christmas lights. Newer strings have LEDs, and that's not. And for my ideas, it's not good because they're harder to take out on wire, and they need more complicated circuitry like regulators and resistors, unlike these bulbs. Anyway, here we are. We're ready. Let's plug them in, and let's see it light up. As you see, they light up, and for safety's sake, let's put them away from paper so they don't burn down or catch fire or anything. Let's turn off the lights. Excellent. perfect. It works. And they're also pretty wonderful. Don't you think? And they're good lights too, mind you. Let's turn off the power supply. And let's come into the heater. Let's build a heater too. And there's some more good news to that. And now for the heater, we need a transformer, a UPS transformer, one of these two, or even both of them. But we don't need one. Both of them will melt the spring. We only need one to make a heater. And because I'm not the brightest spark around here, I killed my driller battery, so it means I can't run the inverter. So I have to connect them directly to the mains. And if I connect the spring to the mains, it'll blow the fuse, which is terrible. So I have to use an isolating transformer like one of those. And no, they're not very actual auto transformers. So we're set. Let's wire it up. Now the advantages between these two are that the differences between these two are that this one is grounded and this one isn't, while this one has a tap on the primary for the inverter, so you have 120 volts for Americans, and this has a tap on the secondary for higher current. This is the tap, and these are 12 volt and connected to 6 volt output, and these are the mains lines, and there's no tap. So we're using this one because we need higher current and lower voltage, and because the spring resistance isn't too high, it should work. And to wire it up, we have to get the plug from the harness of the inverter video I showed you a few weeks back or months back of the inverter testing, and I take out the connections to the electric motor which I connected today for some motor experiments, and I connect these two to the transformer lines. If you can see them. Get them to the transformer lines. Like so. Watch.
Hold me close.
And because the UPS transformer can deliver lots of current, the winding can take it for some time. Before I get another smoking cheese brulee or something. Anyway, here's the circuit finished. The second are going to the mains, and the tap going into short. And no, this is not neutral. This is because of some electrical tape, because of some exposed wire, which is very dangerous. Now the next step is getting our special resistor, which is supposed to glow red hot. Well, not supposed to, but doesn't burn out like this. Like this spring over here, and this spring should be connected to these windings, and the current going through it is so high, and because the resistance is so high, that it becomes yellow hot, and it generates heat, as I will show you later in the video. Now as for the fan, we will use this 12 volt power supply to power the fans, and lights too, because it's Christmas time, and I'm still wearing the hat, and we have to also power. And I have to power the fan with the power supply, and this is how you do it. So I have two fans, this one and this one. This one produces, both of them produce strong wind, but this one produces, very strong wind over a tiny area, but the size of a blowhole. But this one produces wind the size of the entire fan. So this one produces more air. This one pushes more air. So we're using this one. Now, for this fan, the positive and negative wires are as follows. The grey is the positive and the black is the negative. So it's connected like this. The positive of the power supply, which is the one with the white streak, is going to be put in a Wago. The power supply for the bulbs, because yes, it's Christmas time and I love Christmas spirits, is going to go in. It has to be a load to load the power supply and also to be Christmassy. So it's the live wire of the power supply. Well, it's not live; it's 12 volt DC. And we also have to plug in the positive wire of our computer fan, which is the heater blow fan. And the best part of this is it's adjustable voltage. But that means even the Christmas light voltage brightness will be adjusted from the voltage adjustment of the fans. Back to our story. Like that, we will have that. And then with the negative of the fan, we connect to another Wago. 3-pin again. And connect the neutral, the blue wire, because it's the negative of the bulbs. Brown for positive, blue for negative. And then we also connect the negative of the power supply there, because this one is the negative. Like this. Good. It's not fits. And the negative of the computer fan also goes there. Now, if you plug the entire setup in the mains, well, after I fix this Christmas songs. Anyway, if I plug this in like that, and you plug it in, watch the fan rotate, and also some wind being blown on the camera, because the wind from the fan is very strong. It's a very powerful computer fan. Rotating, and I'm feeling some strong wind. And now, watch the lights as I adjust the voltage. Watch the fan as I adjust the voltage. This is a very terrible setup. Anyway, watch the speed of the fan as I adjust the voltage. 12 volts, everything good. At 9 volts, I see the speed of the fan and the brightness of the bulb reduce significantly. If I reduce it to 7.5, everything reduces even more. 6 volts. Oops. At 6 volts, at 4.5 volts, at 3 volts, and that's the lowest it can go. And at the highest, it's all good again. But there's a catch. Look at the bulbs. At 12 volts, they're all good, la-di-da, lovely. At 9 volts, 7.5 volts, 6 volts, 4.5 volts, oops, 3 volts, and that's our disadvantage. Once the voltage across the fan drops, the voltage across the bulb drops because they're connected in parallel. So we need some kind of boost buck converter regulator, which I don't have. So I'll have to stick to this junky setup for the time being. Oh, and unfortunately I can't leave this fan, I can't leave the Christmas lights on because I have to move the fan down there. But I'm not going to make a red hot heating element on the table, or it'll burn my books and also my fan and the table. So I've got to do it on the ground because the ground's not flammable, unlike my table. So let's put everything on the ground and also remove the Christmas lights. Okay, so here's how it's gonna work. So here's our transformer, and here's our computer fan, which is currently rotating because for demonstration. Once you plug the transformer in the mains, the current across the filament becomes so high that the filament glows red, yellow hot, and what am I gonna do with that? This is when this fan comes in. This fan blows the air from the heat energy from this out there, and that's what makes the heat center. And the better thing about this is that you can control it, adjust the fan speed, and turn off the element completely. I can also make an element controller by putting a dimmer on the parameter, but I'm not, because I don't have a dimmer first of all. And second of all, if I had, if I burn it, I'm in trouble. Anyway, this part sucks in the air and it blows it out, and blowing the air out of the heating element like that. You can test it on both sides, like this and like that. So the air is being blown on the heater element. That is if the heater element doesn't blow away. Let's plug this in the mains and see what happens. And before we do the transformer plug into the heating element, let's measure the voltage of the transformer on no load. We plug it in and turn it on, and this is no load, so it's safe. The voltage in alternating currents about 5.6, 15.6, 7.8 volts, and the current is, well, let me turn it off. And the current on the short circuit is so high, the fuse will melt, and probably the meter will melt too, which is why we're connecting this instead. Let's test it out. Oh, and because safety first, I have to insulate these. And the power is not on, I turned it off for safety reasons. And now let's put the Wagos on these two, because we do not need them, and now they can short out and blow up everything. So let's isolate the tree if we can. So there we are, we're finished. We've isolated these three, and all we have to do is put these wires in a safe place so that the heating element doesn't melt our insulator. The thick wire can take the current, but the thin wire cannot, which is why it turns yellow hot. And because I'm so stupid, one of the propellers of the last fan broke, and then the circuit fried. Why? Don't know, because I'm an idiot. So I have to use this one now. Why is my life getting worse and worse? Anyway, back to the video. Okay, so while trying to build the heater and testing it for the video, the fan works, granted, but there's some bad news, and this is regretting too. The springs are not meant to be used as heating elements, because over time they can melt, and you have this black stuff on my finger after it's cooled down, and becomes more and more easy to break. It becomes more and more stiff. At least some parts do. And it becomes very smelly and it doesn't work. So, bad heater project. Don't do that at home. But I'm not gonna let you down. I am going to build one final thing that's sure going to leave you in, I don't know what, or something. I'm going to build a Santa Claus burglar alarm. What do you think? Dramatic? And I'm going to part using this power supply. Even more dramatic? Okay, whatever. Let's get building. And here it is, the finished result. So this is the power input, and this is the transistor which drives the controller. And the transistor, and this is the burglar wire. If it ever snaps for any reason, the transistor will turn on and stay on and on forever until the power supply turns off. And it works like this. And this is how it works. For more details, see my video, burglar alarm circuit. It will give you in very extensive detail how it works. But this is how it is. And this should be the trap for Santa Claus, so maybe we can catch him with this trap. And instead of batteries, you're gonna use this power supply, because for the simple reason that batteries voltage drop over time, and they're not gonna last forever. Well, the power supply can last you a very long time, well, until there's a power cut. Hope there is no power cut this Christmas. Let's plug it in. Oh, and by the way, you should have someone supervising you to plug it in. So here it is. So this part is shorted out for the burglar alarm, and these two are connected to the base, and then these two are connected to the base, and no, this should never be connected anywhere, ever, ever, ever. If it's weird, it'll blow up the transistor and pull the rest of the circuit. We're connected directly to mains, so don't ever do that. I got this wire from a mains plug. So this is the wire, the trip wire, and we're not using a laser in this case because it doesn't become too easy. We don't have a laser. I still don't have one. So connect this to that, and up to that, and short it out. So now the base is short and connected. And I made this other end here long on purpose that you can fit this on some table or chair or something like this. Watch. This part over here. Oops, sorry. Like this part over here, for example. Lift the table. So there it is, connected like that. Well, it's connected on the table, so it's a tripwire part. And then we connect that to the circuit. We're going to pretend to have the circuit somewhere safe. So it's one more trips on the wire we can activate because the wire is cut. This is not a very efficient method, but Santa only comes once a year, so I don't have time to change the wire. Oh, and I also added, for simplicity and for lack of visibility, this wire insulator and dishwasher. So if this is pulled, this cuts and alarm triggers. And I also added some more horns, a flashlight, no criminal identifier, and some alarm red lights. Let's try it out. Oh, I think he's too stupid to pull the burglar alarm. Oh, there's only a light there that makes me happen. Who cares if... Oh, turn it off! No! I must admit I make a pretty stupid Santa Claus, but my burglar alarm worked. I'm actually got Santa Claus. Maybe I can touch him for more presents. Try it out at home, and try to catch Santa so you can get more presents as well. And if this video is posted on Christmas Day, try it next year. Or try to catch Easter Bunny or the Fairy or whatever.